Hello, guys. Welcome to another episode of CUDA Education. Today, we are continuing our path of getting from a blank, fresh project in Xcode all the way to our modern renderer project, which is basically a bistro scene, a very realistic and advanced rendering application that is of a bistro scene. And you could look at the previous videos and all that stuff and the episodes that I've worked on before to see to see the bistro scene. It's basically in the Apple Metal sample code library. Just look up modern renderer, and then you will see sort of the project that we're working towards. So we start with a fresh, clean project in Xcode, nothing in it, just the default situation, and then we work our way to that project. There's certain settings that you have to choose when you're setting up the fresh project, but I have that in the very first clean slate video, or the first couple videos anyway, of how to do it. All right, so we're continuing our path. We are on item 3 right now. I did the first 2 items in the previous video. It's sort of, this is a subsection of, I think, step 4. So I plan on doing basically 3, 4, and 5 in this episode. Okay, so 3, 4, and 5. So let's get at it. So we're at AAPLMaterial.h. This is a header file that is AAPL material. So this guy right here, which I'm currently in. So abstract header for structure describing material properties. Let's see. So material properties. A single data entry struct describing a surface material. Fallback colors. Base color, metallic roughness, emissive color used when textures aren't available. Texture hashes. Base color, texture hash, etc. Used to look up textures in the texture manager. Boolean flags has base color, texture, etc., indicating which texture maps are present. Opacity for transparent surfaces. Okay, so these are all the things that is going on in this particular file, AAPLMaterial.h. So we import SIMD, which is used a lot for just our capabilities and data structures and stuff that we need. SIMD stands for single instruction, multiple data, what have you. I have a whole video on that. So data only structure storing encoded material information. So we have a strut called AAPL material, and then we have a whole bunch of things inside of the strut. Base color, texture hash, base color, texture, has diffuse mass, metallic roughness hash, has metallic roughness texture, normal map hash, has normal map, emissive color, emissive texture hash, has emissive texture, opacity. So has base color texture is flag indicating a valid diffuse texture index. Base color texture hash, hash of diffuse texture. So you could see, guys, that a lot is going on, but the file is actually pretty simple. It's just this guy right here, and that's it for material, AAPLMaterial.h. So we know that if we set up a strut this, we have all of these things that we have as part of the strut. Okay, so let us go to the next file. So we have AAPLCommon.h plus AAPLCommon.mm. So I guess you call this a main file, and then we have a header and a main file. Utility functions. So let's pull that up. So we have AAPLCommon.h, AAPLCommon.mm. Okay, so small utility functions used across the code base. Align up rounds a value up to the next multiple of an alignment. Used for GPU buffer alignment requirements. Divide round up. Integer division that rounds up instead of down. Used for computing dispatch group counts. Get app name. Gets the app name from the bundle. Get or create application support path. Creates a directory for storing app data. New compute pipeline state. Helper to create a metal compute pipeline with proper error handling. So of course, guys, we're just we're just in the discovery stage right now. This is I guess, I mean, this covers the header and the main file, but let's actually dive into the header and then we'll dive into the main. So abstract header for common application utilities, import metal.h and import simd.h. So we have a line up, divide, round up, divide, round up. But notice that it's two different types. Same function name, but two different types. Return name of app / executable, get app name, get or create application support path, and create a new pipeline with a label and asserts on failure. So MTL compute pipeline state. New compute pipeline state, library, function name, label, and function constants. I think I've seen this before. Maybe this AAPLCommon.h was here before or something. I don't know, but I think I've seen this before, right? Because we did have to create a new pipeline at some point. But new compute pipeline state is this guy. We have library, function name, label, and function constants. Okay. Now let's get into the main file for it. So let's see what this actually affords us. So implementation of common application utilities consistent with the header file. Import foundation / foundation.h. I haven't seen this import before. Maybe at some point I'll ask about it. And then import our header file AAPLCommon.h, right? So that was a file that we just looked at. So we have a line up, divide, round up. I guess this is now the actual heavy lifting of the applications that we're doing. So you're actually doing the calculations and stuff now, right? Right, so you're actually doing the heavy lifting. Get or create application support path, all of this stuff. We have our fail to obtain an application support directory at XYZ 1 2 3. And then now we're actually creating the compute pipeline state here. This is the heavy lifting for all of that. Not going to get too bogged down in details here. We're just, I'm sure at some point we'll have to dive into it in a little more detail. But for now, we just want to know that it exists. I do always like to look at the failure messages. So fail to create metal kernel function. Okay, so that's one failure, compute function. So I guess if you want to do some compute and it fails, you get this message, right? And then there is fail to create compute pipeline state, right? So maybe this is the big wig right here. And if it fails, fail to create compute pipeline state, and then return pipeline, okay? So we have all of this. This is the signature of the function and everything, and then we're supposed to return a pipeline at the end. And that is that. Okay, so this is the AAPL common header and main file. All right, AAPLAsset header and main file. Binary file loading. This is the file input-output layer that reads bistro.astc.bin file from disk. Now, this is actually a main, let's go to it, AAPLAsset. So let's go to the header file first. So this is actually a kind of a big deal, guys, or very much a big deal, because this is the main, I think this is the main stuff that loads the bistro scene, right? So all of the wonderful things that we see in the scene, and the drawings and the geometry and the everything is being loaded from this file. Now, there's special processing to do it. There is also like compression at play. So apparently with the modern compression, it's like way lower than like the previous generation of compression. A lot of stuff going on here. But let us just dive in. So AAPLAsset.h and AAPLAsset.mm binary file loading. This is a file input-output layer that reads a bistro.astc.bin file from disk. Let us see. We'll just do up to. Okay. So decompression functions. The asset file contains data compressed with Apple's compression.h library. Each compressed block has a APL compression header, compression mode, uncompressed mode, size, and compressed size. So I'll read that again. Each compressed block has a APL compression header, compression mode, uncompressed size, compressed size. Uncompressed data calls compression decode. Buffer to decompress. Uncompressed data calls compression decode buffer to decompress. The block callable variant lets the caller allocate the destination buffer. The block callback variant lets the caller allocate the destination buffer used for APL mesh to decompress directly into GPU buffers. Okay. APL texture data describes one texture from the asset file. Dimensions, pixel format, MIP count. Byte offset length/length into the texture data block. Per MIP offsets and lengths for individual MIP level loading. Conforms to NS secure coding for serialization. All right, so that's AAPL texture data, guys. We have AAPL mesh data. The top level asset container, compressed NS data or NS data blobs. Compressed NS data blobs for vertices, normals, tangents, UVs, indices, chunks, meshes, materials. Counts for each category: opaque, alpha masked, transparent. Array of AAPL texture data objects. Mesh with file name. The main entry point finds the file in the app bundle. Memory maps it with mmap. Maps file pages directly into virtual memory. No copy needed. Reads the AAPL file header. Magic number plus version check. And deserialize the archived data with NS key on archiver. So that's AAPL mesh data. So it's the top level asset container. I guess at some point we'll get into that in more detail. But let us move on. Block compressed texture helpers. So get DC properties. Returns block size per bytes per. Returns block size bytes per block. Channels for BC1, BC3, BC4, BC5 formats. Intel/AMD. Get pixel format block description, DSC description. Defaults to ASTC 4x4 Apple Silicon, falls back to BC properties on Mac OS. APL. Oh, all right. So yeah, we'll just stop right here. We'll just stop right here. All right, because that's too much. So this is all of this right here is for the AAPLAsset. This is for the AAPLAsset header and main file. So this is the header file here. Header for classes which read texture and mesh data from file. So I'm not going to go through everything again, but we do want to at least just look at the instructions and see what's going on. Uncompress a block of data to another block. Calculates the size of an uncompressed block of data. Uncompress a block of data to dynamically allocated buffer. We have some logic if it is an iPhone or not. So if it's an iPhone, then we do helper to get the properties of block compressor used by this sample, right? And then otherwise, yeah. So that's just only if it's an iPhone. Class to decode texture content from binary data. All of this stuff, guys. Indices for rendering chunk data in AAPL mesh format, material and data, all of this stuff. So we have our work cut out for us, guys. We do have our work cut out for us. So this is just the header file. All right, we haven't actually gotten to the main file. So implementation of classes which read texture and mesh data from file. We import AAPLAsset.h, right? The header file, compression, types, stat, on istd, mman, nskeyed archiver, mesh magic, mesh version. So we have a strut of AAPL file header, AAPL compression header. Get compressed header, and then we return the header here. Uncompressed data size, return get compressed compression header data uncompressed size. Uncompressed data, uncompressed data, uncompressed data. If target OS iPhone, helper to get the properties of block compressed pixel formats used by this sample. Right, so this is our special iPhone processing. So if you're trying to run the application on an iPhone, you got to do this stuff. Get pixel format DSC. APL texture data, encode with coder, APL mesh data, All right, and that's it for the AAPL asset main file movie. So a lot going on, guys. As I said previously, we are getting into the heavy lifting. This goes all the way down to here. So we're getting into the heavy lifting, guys. But we shall, as we get right now, we're still at the triangle, right? So we have made some changes. We have made some changes in the background, but right now we're still rendering the we're still rendering the triangle. This is again just the background legwork, foundational stuff that we have to do to set up ourselves so that we could receive and process the bistro scene when we are ready to do so. So we kind of have to go through this, but literally the next major step after this is to actually render the bistro scene. Now, I don't think the bistro scene is going to be fully complete once we actually get something on the screen. We'll still have to do some work to get more things done. Because yeah, it's just a lot going on in that scene, in the bistro scene. So this is Code Education, guys. You know the deal. I don't even have to repeat myself anymore. Help the community, help the channel. You know what the deal is. If you know anyone in your community that's artistically inclined, creative, is gonna make the next what is the latest thing now? Toy Story movie, the next Avatar, whoever is creatively inclined, get them involved in this stuff. I know it's intimidating, but that just makes the victory that much nicer. So yeah, guys, this is Kuda Education. I will continue on the steps. There are more steps to this, but yeah, we're just going through it, guys. So just a quick overview. We went through AAPLAsset header and main file, AAPLCommon header and main file, and AAPLMaterial header file. So the AAPLMaterial file is material properties. AAPLCommon is utility functions, and then AAPLAsset is binary file loading, right? So you see how much work we have to do just to load the file. And there's a whole industry around just creating assets. I think that's one of the biggest costs of any kind of computer graphics project, is just creating the assets. So you could see that just the loading of the asset is a lot going on, right? Because you want to make it realistic, and the shadows and the textures and all that stuff, right? But we're on our way, guys. We're on our way. We're trying to get to a way better place by the end of 2026. We are now in the middle of 2026, so let us just keep pushing and be in a really good place to welcome 2027. Thank you guys for watching. Have a great day.